Hello everyone. So today we are going to be talking about power and energy. These are two things which are often confused with each other, and here we're going to straighten them out. Just as a bit of a refresher, in the past we've talked about Ohm's law, where voltage is equal to current times resistance. And so power is very related to what we've already spoken about. Power is essentially the rate of energy consumption, and you can see that in its formula. So this is the formula right here, and you can see that power is equal to voltage times current. And so it's how fast we use the energy, while current is the flow of the electrons, and voltage is the potential energy within a circuit. So it makes sense that power is how fast we're using that energy. So if we go back to our marathon analogy, we have lots of people running past a specific point in any given moment. And so our power is equivalent to the number of people running past that point at that specific moment. We have our little power triangle up here, so power is equal to current times voltage. And important to know is the unit of power, which is the watt or kilowatt, where 1 kilowatt is equal to 1,000 watts. So just like your normal metric units, where 1 meter would be equal to 1,000 kilometers, okay? Now, some of the practice problems you'll be working through will be just like our Ohm's law problems, where I give you two of the variables and you have to solve for the third variable. At times, you're going to have to use first one triangle, then the other triangle. So let me show you an example of that. So here's a bit of a practice problem I pulled up. I'm told that power is equal to 20 watts. Current is equal to 4 amps, and I want to know what resistance is. Well, I know what power is. I know what current is. I know current over here, and what we want to know is this resistance. Obviously, I don't have enough information to solve using Ohm's law, which means I first have to solve for voltage and then use that over here. So that's what I'm going to do. I'm going to rewrite my formula, P is equal to VI, and plug in my values. So this is 20 watts volts times 4 amps. In order to isolate that volts, I'm going to divide both sides by 4. This cancels out, leaving us with volts. 20 divided by 4 is 5, and we know that the unit of voltage is the volt. So now we have enough information that we can use our Ohm's law, and I'm going to rewrite that formula. Volts is equal to I times R, where our volts is 5. Our current is still the same current, and we're solving for resistance. So we divide both sides by 4. And so we have some things canceling out, and we have a resistance of 1.25, and remember our units of ohms. So that's basically power. It's the rate of energy flow, or the rate of sort of consumed or transformed energy. You'll see it referred to a few different things, and the units of power is the watt. Now, we also need to talk about energy, because I said that they're confused all the time. Well, energy is sort of electricity or power used over time. So power is an instantaneous measurement. So it's at a specific point in time. It's instantaneous. Whereas energy is over time. So we see it as power times time. Power is usually measured in kilowatts because when we're talking about homes or appliances, it uses a lot of watts. So we talk about it in terms of kilowatts. Time is usually in hours. You might notice some of your questions will have time in minutes, in which case you'll have to convert to hours. Or if we start out in watts, you'll have to convert to kilowatts. So using our example over here, we started out in 20 watts. In order to find the energy, where energy is equal to power times time. So our power here is 20, but we need it to be in kilowatts in order to use our energy. So we're going to transform that to by dividing by 1,000, and we get 0.2 kilowatts. Let's say that we were given time is equal to 270 minutes. Well, we know that we need to transform it into hours, and so to transform it into hours, we're going to divide by 60 minutes because we know we have 60 minutes for every hour. And so that gives us 4.5 hours, or 4.5 hours. From here, we can calculate our energy. So energy is equal to 0.02 kilowatt times 4.5, which is equal to 0.09 kilowatt hours. So this is all important because when we're charged by the hydro company for the energy that comes to our house, they charge us by kilowatt hour. So let's take a look at this example. A hairdryer has a power rating of 120 watts. So right away, you should start highlighting these numbers, and we know it's power. If Susan uses her hairdryer Monday to Friday for 15 minutes a day, and there's time, how much energy does she use? And we want to know energy. Okay, so I read about our values. Right off the bat, we see that power is in watts, so I want to turn it into kilowatts. To do that, I'm going to divide it by 1,000, which will give me 1.2 kilowatts. And we see that minutes, we're going to have to do some calculations as well. So it says from Monday to Friday for 15 minutes. So that means 15 minutes times 5 days, which is totaling 75 minutes. But again, we want to convert to hours. To convert to hours from minutes, we're going to divide by 60. So we get 1.25 hours. You can think of it because we know that every 15 minutes is equal to 0.25 hours, and every, 60 minutes is 1 hour, right? So, using our energy formula, where energy is equal to power times time, so our energy is equal to 1.2 kilowatts times time, which is 1.25 hours, gives us an energy of 1.5 kilowatt hours. Now notice our second question says, how much would it cost to use her hairdryer if it costs 14 cents? So our cost is going to equal 14 cents per kilowatt hour, okay? In this case, I find it easier to work in dollars. It's just more straightforward. So I'm going to take that 14 cents and convert it to dollars by dividing by 100, because 100 cents is equal to $1. So that gives me 0.14 dollars. Okay, so it's 14 cents. In order to find the cost of using the hairdryer, we need to take the amount of energy used and multiply that by our cost per kilowatt, which was given to us in our question. So to plug in our values, we have 1.5 kilowatt hour times $0.14 per kilowatt hour. And the reason this works out is because we have this canceling out this, which leaves our unit as dollars. So 1.5 times 0.14 is equal to $0.21 or 21 cents. So not very expensive at all. So those are two new terms for you today, power and energy. Give some sample problems a try and good luck.